Hello and welcome to the Korea-US NextGen broadcast webinar, a super session where speakers from both countries will share their ATSC 3.0 technical innovations. I'm Josh Gordon, a TV industry strategist and your moderator for this event. This event comes at a critical time in the deployment and development of the ATSC 3.0 standard. I can recall a time when only 3 years ago when advocating for next-gen TV was like pushing a boulder up a hill. But times have changed a lot. Just in the last few months, there's been a lot of very positive feedback about next-gen TV station launches, which will soon cover half of all US. All Sony TV sets sold in the US will receive next-gen TV. Jamaica becomes the third country to move forward with the ATSC standard, and positive signals are coming out of India. It feels like maybe, just maybe, the scales are starting to tip in our favor. The question I'd like to ask is, are we reaching a tipping point just yet? I think that through this conference, I think we're going to hear a lot of news that supports that point of view. Some of the information that is going to be shared here is going to be quite positive as well. You'll hear from Castera's CTO on their work to simplify TV station operations through software infrastructure systems. Today's address will be Castera's first publicly facing description of this new technology. You'll hear from MBC, one of Korea's major 3 broadcasters, with a description of their precision broadcast RTK service, which adds extremely accurate GPS to a wide variety of industrial applications. At this time, I'd like to turn the program over to Jae Jeong from RAPA, who has been the driving force behind this event. RAPA has been one of the most aggressive proponents of the ATSC 3.0 standard. Jae, tell us more about how we came to be here today.
Hi, appreciate Josh. Thank you very much. Welcome to the Korea-US NextGen broadcast webinar. As the title indicates, I'm going to talk about the project we are running for development of the next generation broadcast applications and related technologies using ATSC 3.0 standard in Korea. Excuse me, Josh, can you guys see my slide?
Yes, I can see it.
Sorry, yeah. All right, so I'm going to continue. Okay, so my name is Kang-ok Jeon, or Jae Jeong, as my American friends know me. I'm a project specialist of RAPA. I guess we have audiences today from the ATSC 3.0 community in the US watching via online access options. And we have attendees here gathering all together in Jeju Island in the Korean ATSC 3.0 community, meaning that we are still together despite of the pandemic situation. And I hope we'll catch up either in Korea or in the United States soon in the future, as you used to. So if I give you an idea about RAPA very quickly, the RAPA is the Korea Radio Promotion Association, headquartered in Seoul, South Korea. We've been around since 1992, so we just had our 30 years anniversary in October this year. As an entrusted organization by Ministry of Science and ICT, we work closely with the ministry to undertake the government initiative projects. And we are a trading association, so we work on behalf of our members. As of today, we have more than 200 companies registered as members of us. Some companies, you may notice that they are the stakeholders around ATSC 3.0 market in Korea. We have Atsc, Samsung, LG, broadcasters, and ATSC 3.0 professional equipment vendors, and so on. So this is the agenda I'm going to talk about. So we got to slightly see the 4K UHD in Korea. And of course, we're going to talk about the project and test bed and what we have achieved from this test bed. And I'm going to share some of ideas of a collaborate opportunity with you guys. So in Korea, we are very excited about the ATS 3.0 standard and have a history of taking a leadership role in the next-gen TV. In 2017, the 4K UHD broadcast began in major cities, including Seoul, in Korea, using ATS 3.0 transmission. Korean broadcasters are now working on and planning to expand the coverage nationwide over the year of 22 and 23. This means more than 97% of the entire country will be ATS 3.0 coverage by 2023. We are hoping that. And by 2027, we'll complete the transformation of ATS 3.0 by shutting off ATS 1.0 on air. So I'm sure that at that point, we'll have a spectrum repacking to secure frequency in 700 band for other uses, something valuable, could be AK. So there was a quick snapshot of the progress on 4K UHD deployment in Korea. So it looks fine, and we are definitely enjoying the 4K UHD in Korea now. But when you talk about the next-gen TV, we are not just talking about better picture and better sound, but we should also utilize all the features and benefits of ATS 3.0 standard, taking advantage of the ability to be connected with the internet so we can be more interactive and we can provide enhanced viewers experience. Thanks to the efficient coding system and improved modulation technology, broadcasters can now offer data over their broadcast network. ATS3 has an ability to receive a signal from the mobile devices. So we could implement this in automotive applications and create new businesses there. I think Pearl TV is good at this in partnership with the LG. We're gonna talk about it later. And leveraging with the 5G network, the next-gen TV makes it possible to enhance viewers' experience incredibly. So this is all about the reason why we are running this project. We are very excited to develop and deploy data-centric applications, which is our vision. So in order for us to achieve this, we take this way. So we want to test and evaluate prototypes and ATS 3.0 equipment interoperability to develop and verify proof of concepts for future-oriented services. We also want to collect ideas and thoughts around the participants in the ATS 3.0 ecosystem, and we want to encourage and facilitate adaptation of the next-gen broadcasting services. So how does it work? Let's take a look at this. We have built an excellent relationship with Jeju Technopark to coordinate with us on the testing site in Jeju Island. We have two approaches to run the project, depending on whether it's run as public or private purposes. From the public side, the Ministry of Science makes a recommendation of a project. Could be as a part of a government research and development project to test and verify prototypes or evaluate proof of concept. So in this case, RAPA undertakes the project in partnership with related companies and makes a report to share the result. On the other hand, in private side, the Korean Alliance initiate the developing test profiles and submit application to earn the credit to use the testing infrastructure just before they are all good to go. So this is the key players in the ATS 3.0 ecosystem in Korea. You can see some of them you may be very familiar with. So this project is on the way in partnership with these companies, broadcasters, telcos, consumer electronics, equipment suppliers, and so on. This is a picture of the test bed we are talking about, Jeju Technopark, nice, home of the ATS 3.0 test bed. So what you can get by utilizing this test bed is we have test lab with the ATS 3.0 end-to-end air chain system. We also have the transmit network, STL links, experimental UHF channels. We are running 3 channels. So I think it's gonna be good enough to test at the same time, like many different service models. Field monitoring system. I guess I'm running over time now, so I'm gonna go over very quickly. So these are the picture of the towers we are utilizing now. We have 4 different towers, 1 high tower and 3 low towers. Some of them we rolled out single frequency networks with the channel 50. So this gives you a better idea of the coverage of experimental spectrum coverage. This is the labs and equipment. So basically we have all the equipment ready to test anything related to ATS 3.0. Also, we have the ATS 3.0 air chain system with many coordinating companies. We have an encoder, the DS Broadcast, Kai Media, Fixed3. They are good suppliers for the HVC encoder. Signaling, ESG, and Multiplex, Digicab, and Aircode, they are supplying for this. ATBs and Maru ENG, they are manufacturing ATS 3.0 scheduler or gateway. And we have another company manufacturing Exciter, Jinmyung, and Cleverage. This is the achievement we have got in 2021. There are many different kind of various future-oriented services going on in Jeju testbed. Some of them was taken by RAPA, and some of them RAPA just supported for testing and verification of service models. One interesting, we organized this very important events back in April this year. We call the Next Generation Broadcasting Showcase with the C-level executives. So most participants from Minister of Science and ICT, Commissioner of KCC, all the high-level people gather together, and we talk about how important this is, and they promise us they will fully support for this project. Lastly, I'm going to talk about the collaborative opportunities. So what I'm thinking of is we can think of 4 different areas to collaborate each other. We can, first of all, open the testbed to everyone. So anyone who wants to use the test resources in Jeju testbed, you're always welcome. We may want to organize the international forum, sharing information, exchange ideas on applications and businesses. We can also discuss the standard development and framework for mutual recognition of products, if possible. We want to organize the events, some service demo, promotional events. We can use the NAB show next year, maybe. We can further talk detail about this if anybody planning to come to the NAB show next year. So can anyone come to Jeju to test? Yes, bottom line is we feel that our project should be extended to the international level. So we can share the resources we have, and we can contribute our ability for the international participants. For those of you who might be interested in joining us in terms of collaborating for development of technologies and services with ATS 3.0, you can definitely do so by making a partnership with Korean companies you can work with, or directly submit your proposal to RAPA in advance. For the last, in summary, RAPA undertakes a supportive project to assist the next-gen broadcasting industry. The Jeju testbed is fully loaded with excellent test environments. Actually, the Jeju is only testbed supporting real-world tests with a 5G and ATS 3.0 network. Korean Alliance welcomes partnerships with international participants as joint projects. And we would like to organize the international forum to take advantage of sharing information on new applications, businesses, consumer reactions, and so on. So let's work together. We are ready for you. Okay, this is it. Thank you for joining. I'm going to pass it over to Josh.
Thank you. Thank you, Jay. Now let's move on to DigiCap as a presentation. There are students in the US who do not now have broadband internet service. This became a critical issue during the pandemic when students had to learn from home. Junyoung Park from DigiCap is going to describe a successful distance learning program utilizing broadcast spectrum for students living in areas underserved by broadband. Okay, Jun Young, the floor is yours.
Hi, do you hear me okay, Josh?
Yep.
Yeah, thank you, Josh. Okay. Do you see the presentation now? Josh,
No,
do you see the presentation now?
I do not. I think we need to go to the split screen where you're on one side and the slides are on another.
How about this?
There we go. That's it. Great.
Is it working?
It is.
Is
That's
it the regular presentation? Okay, that's good. Okay, thank you, Josh. Good morning and good afternoon. My name is Jun Young. I am from DigiCap. Today, I talk about the latest update on the distance learning application for ATSC1 and ATSC3. Actually, this is our collaboration with the Spectral Lab in the US and the DigiCap. So, literally is a kind of trans-Pacific, the partnership, to make this type of applications working for the kids. So in this morning, actually, John McCaskey at the Spectral Lab shared a news article. This is kind of in a very recent article in the Washington Post. And it says that it started to trial our boxes. Okay, let me check. So I don't know whether you can see it. This is the boxes actually they're in trial right now. So you can check this article later. So, and then I will explain it very briefly what we do in the multiple states in the United States. So this is the typical the use case or user scenario for the distance learning application. So as you can see in the teachers and educators on the left side, they post the the learning material, like homeworks, data files, video files to the we call learning management system. It's a kind of the cloud system. In the US, most of the kids actually using Google Classroom and then Canvas. It's pretty much the same as the way you guys using Google email. And then sometime later, students coming in and they connected their laptops to the Wi-Fi and the internet. They go and check those files in the cloud system, all running on top of internet. Yes, and as long as the internet is working fine, everything works fine, and they're designed in a way that is working pretty much perfect way. But as we know, actually, pandemic gave us realization that internet is not perfect. We need a more effort to make the internet available to all the kids. But in reality, there are still many kids not able to access the internet or have a very limited access to the internet with a variety of reasons, economic reasons and geographic reasons. So we have been collaborating with state government and the municipalities to solve those problems by introducing this Edgecast services running on top of the digital television network. So Spectral Lab, they developed their unique the cloud services, pulling the learning material data from the cloud and then transmit it through the ATSC1 and ATSC3. And then it's actually positioning those learning material data into the home, where we install the Digicaster, Homecaster device inside a home. So for the students' perspective, they don't need to change anything. They don't need to run any new tools. They continue to use their Chromebooks and laptops and Chrome browsers, just switching the connection to the Wi-Fi connection to the Homecaster device here. So Homecaster device, as you can see here, in one end, it has the ATSC tuner and DMOD. It receives the ATSC signal. And then learning material data, we pre-position it inside the storage device, inside the Homecaster device. And then, of course, we have a Wi-Fi and Ethernet connectivity, so that with that, the kids can connect their Wi-Fi. And then, it's pretty much the same experience, the way it's working today, even for example, internet content you guys browsing today, actually pre-positioned close to the CDN inside of your closed ISPs. It's pretty much the same way it's working. The only difference is that we installed the home casting device as a kind of local CDN device inside a home, so that kids don't go out to the internet, just the inside a home, they browse the learning materials. In terms of the equipment perspective, it's pretty simple. It's a one-time installation. Head and side, the ATSC1, we need an IP encapsulator. And for the ATSC3, we continue to use the broadcast scheduler, creating a new dedicated PLP to dump the UDP traffic going through the ATSC. And then for the client side, of course, you need an antenna, and then the home casting device inside a home. And then throughout the US, we have been working with Spectral Rep. Spectral Rep did a very good job to convince the state government. Now we have around 11 states, and then the 4 in the cities, especially Washington, DC. We also have been collaborating with the Sinclair, the WIAV. We actually, right now, it's on the air. The education stream is on the air through the ATSC3. And we hope we can continue to convince the other state government to, it's not the perfect solution though, right? That we actually the complementing the situation of broadband situation where they are today in the United States. And in summary, so like I said, even though it's by the nature of ATSC, it's a one-to-many, it's a unidirectional connection, but by pre-positioning the content, we're actually mimicking and then simulating that interactive, bi-directional online experience for the kids. And also Spectral Rep did a very unique technology to target specific students or a specific group of students so that we can personalize the learning experience for the kids. And that's it. That's my presentation. Back to you, Josh.
Oh, great. Thank you, Jun Young. Great explanation of that service. Okay, we're going to move ahead and talk about a mobile datacasting service. Our next presentation is about KBS, one of Korea's 3 major broadcast networks. And they've created a mobile data casting service and emergency alert system. Dr. Young-Woo Seo, who is Senior Research Director at KBS, will explain it to us.
Thank you, Josh. I'm preparing my presentation here.
Okay, great.
Yeah, just a minute. Yes, let me start.
Perfect.
Hello, yeah, my name is Young-Woo Seo from KBS R&D. Let me briefly introduce the current status of mobile data casing service and emergency alert system. So let's go into the current UHF status. It's a phase 1. So I can see my cursor here. Okay, yes. Firstly, we started from the quality issues. So we started here at the UHD TV, and we also the interactivity for portions, so the end screen smart devices for the media. And now we are focused on from the TDMB to the hybrid mobile service. It's kind of our next phase of next generation TV. So a lot of IP convergence service with set-top box and IP gateway is tried with the smart devices and TVs altogether, which enables the kind of smart services. ESG and indoor reception was the issues. And we already launched a kind of broadcast and broadband services branded TV bar in our UHD service. It was not that successful anyway. It is based on the HBB TV, but now it much looks like a normal OTT service. It doesn't confine its contents to the channel where it comes from. Now we are going to the US next phase. First, mobile service. These days, people enjoy TV as before, but most of the time, they are indulged in mobile for their own contents. This is more common, yes, now for enjoying media. But the problem is that for mobile reception, we need kind of devices, but we don't have that yet. So for experimental services, there are the dongles like this. So every demos we're doing with this, but we are expecting smart devices and car navigation medias with 83.0 chipset embedded. In our R&D, we tried many transmission parameters for mobile and fixed services until now. For test purpose, we maybe 3 years ago, we did that. In our channel, we adapted two systems. For the mobile, 5.5 dB TOV, it's about 2.4 megabps. And altogether, for the UHF service with the TOV of 15.5. So we tried this kind of thing. But QoS is very important for mobile service. So we devised several kinds of handoff technology. This is an internet network handoff between RF and broadband. The video sync is very important for seamless handoff operation. And the next one is that kind of we call the in-band handoff, like Netflix. We send several scales of videos all together, and it can switch it. When the good signal, UHD quality, and bad signal, bad SNR, and HD quality like this. But we are expecting car media system for our next-gen TV service. For example, you see it, a big wide screen, windshield screen, AR window screen, and that is what is that? Flying car, that kind of need maybe precise GPS service. And for the video experience system will be provided. So we can fill with terrestrial high quality media. And the most important mobile service targeted for car is TPAC. It's the transportation information. TPAC includes congested traffic information and public transportation information, etc. for the mobile devices. This is broadcasting service. That means that it can be optimized for the terrestrial network. KBS has started TPAC service since 2005 with TDMV. Our TPAC service has real-time and non-real-time data. For the real-time data, CTT, that means the congestion and travel time information, and RTM, the road traffic message like that. It refreshes every or about 3 minutes. And for the non-real-time data, there is oil price information, gas station information, and safe driving information, point of interest, news, and weather information, that kind of thing provided. For example, I think that broadcasting TPAC has a really good advantage over the telecommunication TPAC because we send every road traffic information at a time in every 3 minutes. That means that on a map, every road condition is displayed. It's very good advantages. And also, we have some kind of information about the branches. We have the alternative for the destination. We made a typical thing. The kind of substitute that we provide the traffic information. And also news and weather information, including EAS. This push service is very useful for the broadcast station and also for the drivers. And advanced TPAC, we are doing the R&D with about that. So that includes a kind of advanced transfer information, including CITS and RTK, location-based service, and mobility services like that. So we are doing experiment here in Jeju, TP, with RAPA and many manufacturers. So next one is emergency alert system. So when big disaster comes, for example, we had a very big earthquake in 2016 and a big fire in 2019. At that time, the cell network was paralyzed. That means that even the messenger cannot work. And sometimes electricity blackout. So we only can use the battery operated radio or smartphone or automobile. That's all. That's only disaster only terminal. And the evacuation to public facilities, so people need some kind of information. So in that case, terrestrial disaster broadcasting and the terrestrial mobile terminals and terrestrial public services, that all three is included in the terrestrial UHD disaster warning broadcasting. So we have made service scenarios for next-gen TV based on IP convergence services. TV can deliver EAS messages through terrestrial broadcast data and IBB type communication network. For example, this slide, in case of earthquake, for example, we can include the earthquake break time and the current influence time, the places, languages, and sound alarm or map information like that. And also, we can include some IBB information like this.
When disaster approaches, the broadcast gets busy. It automatically displays the disaster information that updates every minute on the bottom of the screen. Instead of the internet, you can use the remote control to check various disaster information like 24-hour disaster news reports and action plans for different types of emergencies. On the other hand, the Atsc 3.0 network can be implemented to quickly notify about emergencies from anywhere.
We developed some kind of terrestrial service and
Customized
this kind of smart
information is
device
also
services.
available
And
according to the
TPAC,
viewer's
we
location.
will include the
The
EAS
next-gen
also
broadcasting
here.
service is beyond the simple news report that provides various public data services.
Yes. And also the government and broadcasting companies will also try the public EAS terminal pilot service. That means that with the terrestrial broadcasting signal, there's a special equipment that shows the public EAS. For example, so we send broadcasters and signals, and there's a special equipment. So on the signboard or public place like theater, they can receive the disaster information, or public transportation, this subway and bus. There's a screen and a monitor, and the hospitals or elderly people hear the sound alarm. And we made this kind of standard that we can go through all these kind of devices. So let me wrapping up for the future mobile broadcasting media. First, broadcasting and 5G convergence services. We will maximize service efficiency, and we combine together the broadcasting and broadband services. So all the receivers can receive the same data and apply various situations, and include disaster service reception and response. And convergence service models is a hybrid companion service dynamics like that. So we will expand service quality through active use of broadcast and multicast services. And the next one is the next generation TPIC service that is intelligent traffic information system that includes high quality graphic information and lane-based precise location information with precise GPS and convergence of every terrestrial video, FM, TDMV, and UHD. They will work together, kind of hierarchical traffic information will be provided. So advanced TPIC service through the universal terrestrial video. And the last one is the next generation EAS, that kind of intelligent disaster information warning services. We will expand the concept of disaster to the kind of building collapse or road construction like that. And this kind of application, we made a lot of scenarios. So public transportation and quick updates like that includes the emergency alert service based on location information also. And application of a terrestrial EAS through whole terrestrial video together. So that is the establishment of a social safety network anytime and anywhere by reliable reception of emergency safety information. Yes, that's the end of my presentation. Thank you for your attention. Thanks, Josh.
Thank you. Thank you, Dr. Suh. Okay, our next presenter is going to talk about a cloud-based ATSC 3.0 system. Castera has been developing such a system for quite a while now, kind of under the radar. But today, Stanley Park, Castera's CTO, is going to explain their work so far and at what stage it is in the testing process. Okay, as soon as Stanley is ready, we'll start the presentation.
Thank you, Josh. Okay. Could you see my screen?
Yes. And,
Thank you.
and
Yep. Thank you for joining this Korea US Gen webinar. So I want to introduce the cloud-based 3.0 system. Before that is I'm the Stanley Park from Castadera. Okay, I'm happy to introduce this cloud-based 3.0 system in here. And before going to the main subject, I want to introduce who is the Castadera first. And then our company is leading the broadcaster's digital transformation to the next-gen services. And the Castadera is a joint venture between the Sinclair Broadcast Group and the SK Telecom. And now, actually, the Kevin Gage is leading this company, and then our cloud-based solution is based on the telco industry-proven the private cloud system to enable the ATSC 3.0 for next-gen TV services and 5G for definitely for OTT services for media. And also we are also the support the resource optimizations for efficiency. And we have advanced the AI, enhancement for later on the media and the data engineering side. And also we are also providing the data distribution and security, highly security. And then also the cloud-based system is enabled to support the service chaining to dynamic service chaining and the last one is we are considering the nationwide broadcast service operation as well. So, and our headquarters located in the Arlington, Virginia. And also we have a branch office in Seoul. And we have 2 test beds. First one is the Jeju, and the second one is our Arlington office. So I want to introduce what kind of activity already we are doing in the last 2021 with the RAFA, with the Korean companies in Jeju. So our capability. So what kind of solutions can be provided from the Castadera? We have 3 categories. So first one is laid on the cloud, and the second one is laid on the data and AI, and the last one definitely laid on the media. So I want to focus on first the cloud-based 3.0 system in this here, and then also if I have a chance to introduce later on AI, upscalers, and low latency OTT, and later on the vehicle TV will be coming later. But the cloud-based system is first one is we need to have some reliable and robust cloud platform for the highly available, and also the cloud platform needs to have some open framework to support the multi third parties, the entity and engines for supporting based on the cloud system. And the major goal is the zero touch automations for supporting the OSS in the operating system for the operator, and then the zero downtime. So which means that when you have some kind of the update or some dynamic configurations, still we have seamless services needs to be provided. And then the following and the other item laid on the data and AI and media will be coming later. Okay, let's focus on the cloud-based 3.0 system. So the cloud is, we have in the marketplaces, we have several the cloud solutions, but here is I want to introduce the telco industry proven. So which one is the SK Telecom is already commercial and the use for our 5G networks, 5G services laid on this cloud-based system. So the telco industry is proven distributed cloud 3.0 system to enable the broadcast to quickly to support the build the 4K HDR and through the broadcasting system by integrating existing air chain solutions and composed of the broadcasting equipment And also we are going to with the general purpose servers based on the virtualized 3.0 headend solutions with the centralized operating system. So I want to introduce this cloud system has 3 stacks. The first one is the cloud. So we are based on the common hardware system. For example, the Dell, HPE's, and Intel, IBM's system. That is, we are using the common hardware, and then we can have some kind of software stack for cloud. So the first cloud is later on. The first one is the flexibility needs to be provided, and also we can support the high availability. And again, is we are targeting on the open platform, and also definitely we can support in the DevOps environment as well. And then on the middle of that is for making the several services, including the 3.0 services and OTT services, we can have some middle virtualized media functions for media and AI and data. So supporting on this is we can have open API for third parties for easily to integrate into our cloud system. And then the second one is we can have AI capable. So for example, AI upscaler is training machine learning train base is the media enhancement and the data engineering for operation. And also we have 3.0 virtualized media functions, and the OTT virtualized media functions can be easily to integrate into using the virtualized media applications. And also we are testing with the MBC, so later on the data casting as well. And on the top of this cloud system, we have end-to-end service orchestration layers for supporting the OSS. OSS is operation support system for operator. So this OSS support needs to be supported orchestration of services. So the operator can easily to configure the service chainings and the security chaining. And the second thing is the automations. So operator needs to has easily to configure and automate the monitoring for later on the current existing services or new services. And the last one later on this is the workflow management. The workflow management for the multi vendors, service chainings, and then all of the management can be remotely possible, supported. So for making this, we can provide the 3.0 system with the dashboard. Through this dashboard, we can easily to monitor all of the multi-site as well. So this is the current our test bed in Jeju. So we are cooperating with the RAPA and the Korean government for this under the Jeju project. First one is we completely installed the custodial cloud system at Jeju from 2020. And we are using, you can see the first in the pictures, images here. So this one is they're similar. I mean, the same as the SK Telecom's data centers system. So, I mean, the telco core. So the first you can see the 25G networks we are already using in our telco system, and we have SK Telecom cloud infrastructures for the core management. And also we have now just telco a lot of the focusing on in the mobile edge computing. So also we are installed the 5G MAC for supporting the 3.0 transmissions. And we have several GPU nodes for supporting our system, like on the data and AI. And also we have open collaborations area to lay on the several the project in Korea. And also we have similar system in Arlington as well. So we can have a mirroring site, so which means that we tested with the Korean company and government in Korea, and also it can be easily to test in Arlington area as well. And the Jeju is uniquely supported in the 3.0 and the 5G connection in the world. And we have several tested cases laid on the cloud-based system in Jeju. So a virtualized headend for orchestrations and the vehicle TV. And the second one is the 5G MEC with the orchestrations for AI upscaler, and several scenarios laid on the vehicle and the data castings and AI analytics. Here is some kind of the short the summary of laid on our experiment from 2021. So the first one is we have the right one. We have the configuration of the system. So from Seoul to the Jeju site, and we are the initial version of this orchestrator OSS can manage the multi-site. And we have several tests in Jeju. First one is the OTA and OTT synchronization with the low latency encoder and low latency OTT. And then second one is the OTA through the datacast. We are working with the MBC RTK and the Doosan drone. I think some people already aware of these scenarios and the system. And then third one is vehicle TVs. We are working with the Hyundai Mobis. They are providing the equipment. And the last one is the AI upscaler. So we received the 720p SDR content streams from Las Vegas, and then we are real time the upscale up to the 1080p or 4K, and then the HDR, and then convert to the 3.0, and then we can test it with the 3.0 TV in Jeju. Yeah, some of the videos are showing here. So the TV shows the OTA receiver. So it's coming through our cloud system in Jeju. And then in the small disk, and the mobile is also using the same cloud system through the 5G connection. So you can see the fully synchronized between the OTA and OTT here. So based on this OTA OTT synchronization, we have a lot of opportunities for the various scenarios for the future. And the other one is the drone. So I think is that we also have the NBC will introduce more details later on the drone, the eGPS cases. And this one is already the eGPS also. We use the cloud system in Jeju. And AI upscaler, I already mentioned that, is using the machine learning algorithm. We are continue to optimize the video quality, and AI upscaler can enhance the video resolutions and increase the frame rate, and also increase expand the color space as well. So we are using the multi GPU chip vendors, AI upscalers with the SK also providing the Sapion chip for AI. So we are using on that, so we can real time upscale with our cloud system. And also we have OTT, low latency OTT and vehicle TVs, and we also working with this. And then this one is will be shown quickly. So vehicle TV received the multi-channel broadcasting from our cloud system. And in addition, we can have personalized targeted ad insertion with seamlessly. So this one is we are using the TV service, linear TV services, and also we have NRT services with the targeted ad and the terrestrial VOD. And then our RSC, real estate entertainment system device has mobile receptions quality and OTA OTT synchronizations. So which means that the OTA content from for the main services and then personalized ad will be coming through the OTT connections. Okay, so Castadera is working with the RAPA in Jeju. So under the Jeju project, Castadera is currently working with the multiple companies to build a de facto open standard, open framework, an open API for delivering all-in the hybrid multi-cloud platform for next-gen TV services. So we have several the Korean companies, and then we are working hard, and then also we have a big achievement, and then we are looking for the next opportunity in Korea and the US market as well. Thank you. And then also I'm really excited for the next, the cases for the future. Thank you.
Thank you, Stanley. You guys have been busy. Okay.
Yeah,
All
we
right.
had a lot of busy time.
Okay, very good. Okay, our next speaker is going to talk about ATSC 3.0 NRT handoff. Sang-Jin Yoon from DigiCap. He's going to talk about the data handoff, which occurs when wireless mobile devices in cars or phones pass from one signal source to another. And he's going to describe how this technology is being applied for passing between ATSC 3.0 broadcast towers.
잠깐만요. 그것도 아니고. 어느 자료죠? 여기 올려놓지 않으셨나요? 네, 없는데? 아, 이거다. 네, 있습니다. 풀 스크린으로 가면 되죠? 이렇게 하면 됐나요? Okay, my name is Sang-Jin Yoon with DigiCap. For those of you who know me, I didn't change my job. Just merely filling in for Mr. Jin-Pil Kim with LG. Good evening, America, and good morning, Korea. I'm going to talk about ATSC 3.0 NRT handoff proof of concept implementation and testing that we've done with LG. So as the name implies, it's handoff, NRT data casting. So we believe that this was a very important milestone that we have reached for various reasons. But the main reason is test was done on the automotive environment. Why are we doing this? When we set out to develop ATSC 3.0, we all know that mobility is the important part of in the fabric of next-gen TV services. And so when you look at some of the key features of ATSC 3.0, they embody in one way or another enablers for mobile services. Those include on the physical layer side, higher capacity, configurability to set multiple PLPs, each dedicated for either mobile service or fixed service, single frequency network, hybrid broadcast broadband services, real-time media, as well as non-real-time data delivery. And there's several more items, but I'm going to skip to that. So next few slides describes all these features. So I'm going to skip those slides and go right off to the what we are doing here. So when you look at the US and also Korea, there are pockets of transmitter sites, RF coverage areas, and so many of them. And they are in most part overlap with each other. This gives us the environment in which we can still do handoff. So when I say handoff, let me just stop and say, it's only natural to expect that we do handoff to enable mobile services. That is the core of it. Your mobile handset right here we do cell-to-cell handoff. That is how we move around the country to get the same voice and data services, no matter where you are. So it's natural to expect that we have tower-to-tower handoff to get the services, to continue to receive services, no matter where we are. So we did a handoff on the multi-frequency network environment. And this is simplistic view. LG and Digicap implemented on the emission side technology and the receiver side technology for the automotive, what we call RSC, people called it, rear seat entertainment, to continue to receive the same services, moving from one coverage area to another. So the technology that we've implemented on the signaling side, that's on the head end, is sharing from tower to tower. It's a sharing of the description of the other tower's service. And on the receiver side, there is a background tuning where the receiver continues to tune to signal from adjacent coverage area. And when it locks on, it will receive the description of the currently receiving service coming from the other tower, and it will continue the download of the datacast service or the AV service as well. So field test configuration that we've done in Jeju Island is that we had a 2 transmitter site, each receiving data from separate transport chain. Now, mind you, the transport chain, the head-end system, they were located in lab and Digicap site in Seoul, Korea. We have Korea Telecom has provided the dedicated broadband pipe coming from the mainland Korea to the island of Jeju, and where we emitted STL over SRT fan out to the transmitter site, exciters and located in Jeju transmitter sites. And as you can see on the top middle, there's a data orchestration server that emits the same data to both the different transport chains. Now on the receiver side, LG has implemented the rear seat entertainment system as the 2 tuners, each receiving, tuning into a different frequency. And with the lock, it will go all the way up to the app layer to where it has the intelligence to switch over the services. So this is a simplistic UI, demo UI that we've shown. Is the main screen, that's the TV screen. And on the right-hand side, it gives you the information of what AV services are being received. And on the right lower side, the black window pane that you see is where we have a progress bar for the datacast reception that the receiver is getting. So I don't have the video here now, but what has been seen on this UI is that the progress bar continues to move even while you're crossing over a different coverage area. So this is a setup in Jeju Island that we've tested, although it's not it's more of a concentric coverage area. We had a large 900 watt channel 24 tower that's covering the large area. And we had a smaller 400 watt channel 51. So we had not 2 different coverage areas just touching each other, but we had a pocket that's in the middle of a larger transmission area. And the test was done with the automotive with RSE going in and out of that blue pocket in the middle. So this is what you saw, what you will see on the screen, and handoff has occurred. It will show you has happened from what physical channel to which physical channel that has moved. And in the future in Jeju Island, we do have other transmitter sites, and we are going to test it in such a way that 2 sites will only touch each other. So for next step, this is only the beginning. So next step, we have to do more tests to really achieve full mobility. So we just completed the field test in US, in Michigan, Detroit, Motown, proving ground, test ground. So I believe Ann Shelley at Pearl TV will share more details about the Detroit Motown. Test in more complex overlapping coverage areas, more complex the topology of towers. And we want to do standardization for industry adoption. And we need to test more with different PHY configurations, data sizes, types of data as well, security, and targeting, who receives the data, and also QoS. This is very important. So with this, I conclude my presentation. Thank you very much.
Thank you, Sang. It was great. I appreciate that. By the way, you're absolutely right. Ann Shelley from Pearl TV is going to talk about how this LG Digicap collaboration system is going to be tested and has been tested in the Detroit area. And when we have the American speakers on, she'll give us a lot more detail about that. So, okay. Okay, next we have a speaker from, who's going to talk about RTK and the ability to have precision geotargeting. This is an important task for a wide variety of industries. And our next speaker, Mr. Lee, who's a team leader at MBC, one of the major Korean broadcasters, will explain how his organization has already created a business model based on this technology. So I believe Mr. Lee is joining us through a video. Can we start the video?
Hello, I am Seung Lee, the team leader of the MBC R&D business team. Today's topic is to introduce broadcast RTK technology, which is a centimeter level precision positioning technology using broadcast network. The content are as follows. First, let's look at what broadcast RTK technology is. First of all, let me introduce MBC. MBC is a Korean major terrestrial and public broadcaster. MBC has served mobile data services and developed precision positioning technology. Then let's find out why precision positioning technology is important. Centimeter level positioning is essential for fourth industrial revolution, such as autonomous vehicles and drones, precision agriculture, smart construction, and smart city. RTK stands for real-time kinematic, which is one of representative precision position technologies. So how is the RTK system different from regular GPS system? As shown in the figure on the left, the GPS receiver receives only stabilized signals, which passes the ionosphere and troposphere, and usually has a positional accuracy error of about 5 to 10 meters. On the other hand, the RTK system installs a base station on the ground to remove the error component on the path and transmits error correction data to the RTK receiver. The RTK receiver calculates the stabilized GPS signal and the correction data to acquire a centimeter level precision position. MBC has enhanced this basic RTK system to network RTK service for delivering GPS correction data through ATSC 3.0 network. So this time, let's look at the broadcast RTK commercial service in Korea. The figure below is the broadcast RTK system architecture. MBC has built a number of its own base stations, which deliver correction data to broadcast RTK service system. Server system encodes correction data to broadcast RTK correction data format and transmit them through ATS 3.0 transmitter. Broadcast RTK devices receive ATSC 3.0 data. The data are decoded and computed with GPS signal. Finally, computed precision position data is used by various applications such as drones, smart construction and precision agriculture, and so on. MBC has established 40 GNSS base stations in Korea. Broadcast RTK technology maximizes each base station distance up to 40 kilometers, so it helps minimize base station deployment cost. MBC has installed 24/7 service monitoring and various operation systems. MBC has developed also commercial broadcast RTK devices for various applications. From now on, I will show you actual application cases. First one is precision agriculture. It is a big market that already exists. Broadcast RTK technology is applied for precision work and labor saving. Next application is smart construction. Broadcast RTK technology is applied for precision and convenient work. This is an interesting application case. Pizza delivery service using an unmanned drone in urban area. This is a new service model, and the market size is expected to grow enormously. In this video, you can see a drone flying from the roof of a building and delivering pizza to the park. This service has been commercialized and performed since July of this year. Next application is autonomous driving shuttle. Before the commercialization of fully autonomous vehicles, it is expected that these services will become active. Along with autonomous driving shuttle, the market for unmanned ships is also being opened. As you can see this video, you can see that the ship operates automatically and docks automatically. This video is an example of how the driver's license test system is advanced using precise positioning.
경사부리 행실증 보관 이탈 차로 준수 위반, 차로 준수 위반, T코스 증입, 확인되었습니다. T코스 종료, 시험 종료.
MBC is cooperating with leading partners in various fields. In this chapter, we will look at the advantages of the broadcasting network compared to the communication network in the RTK service. First, the network coverage aspect. Cellular network is available only in densely populated area and inefficient to meet RTK needs. But RTK needs happen everywhere, even non-residential area. And ATS 3.0 is the most cost-effective network in terms of CAPEX, OPEX of network deployment. Next is the economic aspect of the consumer. RTK needs will grow significantly and will be expanded from high to low-cost machines. Cellular network cost can be a considerable burden to customers. Finally, in terms of capacity and multimedia provision, cellular network is vulnerable to congestion, but ATS 3.0 is unlimited. ATS 3.0 delivers also free multimedia with RTK question data. This is the final conclusion. In precision positioning business market, MBC has proven technology, cost-effective solution, and business know-how. MBC is open to cooperate with any broadcasters and companies and promises to be your best partner. Thank you very much.
Thank you. What a great video. Okay, that's really great stuff. Looks like we're really making some progress here in a lot of different areas. I'd like to invite all the American panelists now to put your microphones on and join us for some Q&A. And what we'd like to do in this next phase is to have our American panelists ask our Korean panelists some questions based on what they have presented. We're trying to get some interactivity between the two groups. And why don't we just talk about, first, why don't we start with the first presentation Junhyun Park made about distance learning. Does anyone on the US panel side have a question for Junhyun? If not, I have one for him, but why don't you guys go first if you have one? Okay.
I got a technical question. It's less about the application and more about how he described it. And I'm just curious, I believe Junhyun said that they set up a separate PLP for this data. And I was wondering, was that a requirement of the system or is that just how they chose to implement it?
Can you hear me okay?
Yes.
Yep, you can, yes.
Okay, the question was whether the creation of the PLP, is that the way it is or designed, or is it just just design choice, right? Is that the question?
Mm-hmm.
Okay, it's more of design choice. ATSC3 is flexible. If there are many ways to configure the broadcast scheduler. Okay, for the education stream, if you remember going back to the slide presentation that I show you, there's a cloud service in between broadcast head and the learning management system, right? So that the Educast cloud service actually they pull the LMS data, create a UDP, transfer that into the UDP stream, right?
Mhm.
And then ATSC 3 especially is very flexible to transmit to multiplex multiple multicast UDP streams and make it into a single stream and then spit it out throughout the exciters in STLTP, right? So there are many ways to configure the PLPs, different one PLPs, two PLPs, and then yes. So the way we did in a IAV, creating a separate PLP is just the convenience for us to separate that in a specific stream from other television streams.
Thank you.
Yeah.
Okay. Jun Young, I have a question for you. We talked about how students don't have to change their behavior. They can go treat the ATSC spectrum that arrives and is downloaded into the Homecaster device, just as if it were an internet access point. What about the teachers? Teachers have set ways of setting up these distance learning programs. Does your system accommodate how teachers are used to being worked?
So yes, the question is whether teachers need to change the tools to transmit their learning materials over the ATSC 3. Is that the articulation of your question?
That's it.
Okay. Well, actually, there's none. There's no need in the teachers to change their tools. Teachers are very accustomed to use their learning management system, like I show you, Google Classroom and then Canvas. As long as you support, and the teachers know, most of the teachers know how to use those in the learning management system in the U.S. So from the from the get-go, our concern was that we didn't want to introduce new tools. Actually, those requirements came from the teachers, because teachers not engineers. They don't want to change their tools in everyday tools, right? So yes, and then the Spectra Rep developed in a cloud service, actually using the learning management system APIs. Google Classroom has their own APIs, and Canvas they have their own APIs. Spectra has been increasing the number of the learning management system they support. So the teacher's perspective, they just continue to use their learning management system of choice, continue to upload their files, and then everything works pretty much in a background. They don't need to notice any differences, whether it's sending that learning material through the broadband or sending that learning material through the broadcast. It's only the thing is needed is the spectrum side. They just program when because there are so many files in the learning management system, right? You need to schedule it accordingly so that you don't actually blow up the given bandwidth by the PBS stations.
Great. Okay. Super. Okay, we're going to move on to the next Korean presentation from KBS with Dr. Sa. And Rick, looks like you have a question for Dr. Sa. Why don't you just ask him?
Oh, sure. Yeah, sorry. It was actually for Jun Young. And it actually keyed into what you were just saying about blowing up the bandwidth. I was kind of curious if you have any sense of the magnitude for how many schools, classes, and students can be supported. So some of these are statewide deployments, and one station may cover a number of school districts, a number of schools, a number of K-12 classes, teachers and students. So just wondering if there's some sense of magnitude of what kind of load for distance education can a station support?
Mic test. Do you hear me okay?
Yes, very well.
Maybe I didn't capture your question correctly.
Oh,
so
like how many schools, how many classes, how many students?
Okay, how many schools and how many classes? Okay, that in a way, maybe I can answer that question in this way, because this is the broadcast technology, right? For example, if it is on-demand system, right? As we have many schools, increasing, right? We also need to increase the infrastructure side, right? So this is one-to-many system. So actually, it doesn't really care, how many these schools or how many students we need to support. It's just given the bandwidth, right? And also, maybe the answering that question is it's really depending on the coverage, and really depending on how much bandwidth we can be allocated by the television broadcasters. So, for example, today, so one school district, the spectrum rep found that maybe within a day, they transmitting the 100,000 files, under that the 1 megabps, the bandwidth. Of course, you can increase the bandwidth to send more files at a given time frame. So it's very difficult to answer that question because it's not the linear relationship, right?
Okay, sorry.
Okay, thank you.
I think we have to move on to the next speaker, Dr. Sa. Does anyone have any questions for him regarding his presentation?
I was just going to ask is when he talked about the experimental EAS and all of the various receivers that were out there, are those concepts or is that real?
Yes. Yes, in my presentation, and I explained the kind of scenario service. I mean, the pilot and the experimental and scenario is all together. For example, public EAS terminal, it's a real service, but pilot. So we provide about hundreds of special terminals in the signboard, hospitals like that, and on bus. That is a real service, the pilot, and many other smart devices service and other kinds of TV relay service. That is kind of concept, and we just made the kind of demonstration service because for the disaster broadcasting, we should solve many things with government. It's related with kind of laws like that. Actually, in the broadcasting, TDMB is a broadcasting media right now, but UHD, we are trying to get the status of the disaster broadcasting. So we are trying. Yes.
Okay. Now we're running a bit behind, so we're going to have to ask some questions of the last few speakers fairly quickly here, so we don't want to fall too far behind. But how about questions for Stanley Park from Castera?
I have a question. So the cloud-based services that you were showing, are any of the broadcasters implementing those in Korea? I know you talk a lot about test, but has anybody actually physically or commercialized it, so actually paying Castera for that platform?
Yeah, it's quite hard to answer from the first questions. So yes, we have some several NDAs there, and then also we have an initial test inside the current broadcaster system.
Good, thank you.
So yeah, we tried, and also we did a field test here in Seoul.
Okay, yeah, I'm just curious as to how close it is to being commercialized. All of the things that were shown today, all the various use cases, that even the use cases that were shown around automotive would use the cloud infrastructure to enable the allocation of that spectrum. So it's encouraging to hear that it's close, because that allows us to lever that here in the US when we get launched enough. I mean, Korea's been ahead of us, South Korea's been ahead of us in terms of deployment of next gen, where I would say evolutionarily the broadcasters are further along and can support that infrastructure. So yeah, I think the faster you guys actually commercialize it and there is, real companies using the platform, the better for all the use cases I saw.
Yeah. So for more details, things that we plan to commercialize in the early of next year.
Really
And-
next, okay.
Yep.
Good
All
to
right,
know.
thank you, that's
Okay.
helpful.
Yeah.
Great.
Ready to commercial.
Okay. All right, let's move on to NRT handoff. Sang Jin Yoon was speaking. Any questions from the panel on that presentation?
I have the
Yeah.
same question, which goes to, for all those use cases that were shown, is there an automaker that's actually going to implement ATSC3? Is there just, again, if one of the Korean automakers is going to put ATSC3 in their car, that would sure help us with the automakers in the US who are looking for, they're interested in the actual throughputs for the various use cases that were shown. So how do we perform if there's performance data and how we perform on the delivery of files for the various use cases that you guys can provide us here in the US? That would be great for us to be able to put a paper together for the automakers here in the US.
Good question. Any answers? Okay. No answer. No one wants to take that question. What's that?
Okay. Hi. Nice to meet you. JP Kim from LG Electronics in Seoul.
Oh, great.
Yeah. I have a business meeting last weekend and have a Motown NRT test in Detroit. Okay. As you know, it is the very first time and very beginning time. So we have as you know, the LG has a very close connection with a motor company, GM and Hyundai, something like that. So that I think this technology of ATS 3.2 is ready. Technology side is ready, but I think the motor company want to a lot of question to the when will start the automotive service in US and Korea. So I think this question from the Power TV's responsibility is my answer.
Oh, I
Yeah.
was hoping you were going to answer it first in Korea so we could just borrow it from you guys.
It's the same, very
I know
similar. Yeah.
I know we have the Detroit test track, but I was hoping with all the work that I thought that NBC's presentation was really good. And there's a lot of use cases that they showed that it would be great to understand the test results from those use cases. And I was curious, like, are there commercial companies in Korea that have actually done that? That it would be really important to show that here in the US. So I was hoping one of the Korean auto manufacturers would be ahead of GM, Ford, and the US guys, just because they're looking at it for Korea and not necessarily anywhere else.
Okay. All right. Well, that's an aspirational question, I'm afraid. Okay, let's move on to the RTK discussion. So do we have any questions from the panel for questions on that particular topic, geotargeting?
I thought since it was done via video, he was not available for questions. Is that not accurate?
My understanding, is there someone on the panel who can speak for him? Is there, I thought he had a coworker present. Is that true or not?
Hello. Hi, Josh. Hi.
Yes, yes.
Okay. We have one representative from NBC attending here on site, but I don't think we can be able to answer any question about RTK today.
Okay,
Sorry
right,
about
then.
that.
that's okay. All right, then let's just move on. Okay, now we need to change gears once again, and we're going to hear from some of the American speakers. And first up will be Lynn Cloudy. So if we can rearrange our technology to put Lynn on the screen. Lynn is the chair of the ATSC organization, and he's the board chair. And it's a real treat to hear Lynn speak in the United States. We get to hear him a lot. We thought we'd share him with you. He has the mind of a technologist and the heart of a poet, and I've always found his presentations to be kind of special in a certain way. So Lynn, why don't you take it from here? Lynn is going to talk about the current state of ATSC3 development in the United States.
Well, thank you, Josh. You are too kind. It's a pleasure to be speaking to this international audience today, and especially to our friends in Korea. I'm Lynn Cloudy. I'm Senior Vice President of Technology at NAB, but today I'm speaking to you in my role with the Advanced Television Systems Committee, where I have had the privilege of serving as the chairperson of the board of directors for the past 3 years. If I can just get my slide to change. There we go. We have many friendships, partnerships, commonalities between the US and Korea in broadcasting, but I specifically want to point out the ATSC 3.0 connection and talk a little about ATSC 3 in the US and ATSC 3 in Korea and ATSC in general as a bridge between the US and Korean broadcasters. Many in the US are, of course, familiar with the importance of Samsung and LG as technology companies in the ATSC, well-known brands, and they contributed to the development and the implementation of ATSC 3.0. But among ATSC's 150 or so members, over 10% of that membership is made up of Korean companies. And some are well known and some are not as well known in the US, but all of whom have been quite important in the history and the continuing story of ATSC. So first of all, on behalf of all the ATSC board and ATSC President Madeline Noland, I want to recognize and thank the Korean companies on this page. I hope I got them all. And thank you for contributing technology and time to ATSC endeavors. We would not have the excellent system we have now without the contributions that you have made and continue to make. The story of ATSC is a long one, and it began at the end of the US DTV transition in 2009, when ATSC members started discussing about, well, what's next after we go all digital? And so that began a period of planning for the next 2 years or so, and then standard setting began, and that started producing results in the first of the 20-some standards around 2016. And standards for the US were completed in 2018, and stations began going on the air really just last year in the US. But Korea, of course, implemented first, having back-timed from the Korean Winter Olympics of 2018, adopted ATSC 3 in 2016, and stations began going on the air in the middle of 2017. So we in the US recognized the significance of this early adoption. We know it paved the way for the US in many ways and made our introduction of ATSC 3.0 easier and more economical for both broadcasters and television set manufacturers. So thank you and congratulations. In the US, we say Next Gen TV and ATSC 3.0 interchangeably. The former name's familiar to the consumer audience. ATSC 3.0 is more for the technical world, but of course it's the same thing. And the attraction of the many things you can do with ATSC 3.0 would take a long time to fully explain to someone who didn't know about them. So we often talk about an elevator pitch, an explanation that could happen in an elevator ride. So for ATSC, it might need to be an elevator in a very tall skyscraper to have enough time, but there are basically three categories of benefits. And I've kind of color coded them here, green, blue, and orange. Whereas UHD-TV and immersive audio were clearly the initial motivation in Korea. And the availability of 4K images and advanced sound, it made a clear distinction with the HDTV service. In the US, we're also interested in better pictures and sound, but it's hard for us. Full 4K is difficult to implement in the transition because unlike Korea, we did not receive additional allocations of spectrum from the government. So services that require high data rates are challenging for us. In the US, much of the attention is directed on better reception to traditional and non-traditional and stationary and moving receivers, and the lure of personalizing and interacting with the broadcast material. So since we don't have additional spectrum, the idea of augmenting spectrum is very attractive in the US. And these are immediate benefits to consumers. Future extensibility is also a motivator for broadcasters. And efficient use of spectrum is something we like to remind the US regulator about, and that we're using spectrum responsibly. Excuse me. And then the last line is the scary part, really for everyone, that ATSC 3 is not backward compatible with ATSC 1. And the price of a great future is the break with the past. So when the USD-TV transition took place between 1998 and 2009, we had channels 2 to 69. And that was enough for all broadcasters to have a second channel to simulcast DTV. And as a result of the transition and spectrum auctions, broadcasting now only occupies channels 2 to 36. It's just about 50% of what we had in the DTV transition. And the problem with that is that we have about the same number of broadcasters, about 1,700. So the transition is at the spectrum management level very challenging, to say the least. In addition, the way the broadcast spectrum is regulated is quite different. In the DTV transition, because spectrum was being reclaimed at the end of the transition, it was mandated. Broadcasters were required to transition. It was a very strict prescribed time frame. And it's totally different with ATSC 3.0, which is allowed on a voluntary basis as of November 2017, but there's no set timetable, and broadcasters are not required to use next-gen TV at all if they don't want to. So since there is no additional spectrum, we have to share the existing spectrum if you want to do ATSC 3.0. And it's a very simple idea, but it gets complicated pretty fast. There's a red broadcaster and a green broadcaster, and they each transmit an HD signal and two other signals, probably standard definition quality. We call them diginets in the US, and they are lesser quality programming, but they're popular. And in this channel sharing example, all the DTV programming from both channels is put on the green channel, and the red channel is then shared between the two stations for ATSC 3.0. And it works, but each station only has half the bandwidth that they had previously. So it's not something you want to be on a permanent basis. In a typical US market, you might have 6 stations, each with an HD signal and 3 of these SD diginet channels. And channel sharing to free up the most channels for ATSC3 is challenging. So even with the best compression and statistical multiplexing in this example, Mixing and matching would allow at most 2 channels to be cleared for ATSC 3.0. And those channels would need to support the ATSC 3.0 services from all 6 broadcasters. So this is the way it's being deployed in the US. And despite the challenges, we have a lot of stations going on the air now. Roughly 40 markets have begun next-gen TV. A number of other markets plan to go on the air by the end of this year or very soon after. And other markets that are working out their schedule, but they plan to do so. So this is a very successful start to the transition in the US. The orange areas on this map are markets that are on the air. The light blue are markets that are close to being on the air. And the dark blue shows markets that are in the planning stage. But overall, this makes up about 60 markets and about 75% of the population is covered in those markets. Meanwhile, we have TV set manufacturing from at least 3 manufacturers. It is also voluntary. In the DTV transition, it was mandatory. But set sales are off to a very good start. When the first sets really became available in the US in 2020, sales this year in 2021 will be something over 2 million and are expected to be over 31 million in 2025. And that would represent about 75% of all US set sales. So the orange bars on here show the cumulative number of sets. And by the end of 2025, that would be something over 68 million. And at that point, ATSC 3.0 will certainly be considered a mass market and pretty much assumed by consumers to be the future of television, which the television industry already assumes it's the future of television. As far as ATSC 3.0 itself, there is serious interest in countries other than the US and Korea. As you might expect, Canada and Mexico very likely to follow the example of the US, although they'll lag behind. You may be aware Brazil is very active in an international competition for its next broadcast standard, and ATSC 3.0 is one of the very strong competitors in that process, which should conclude next year. And then there's an ongoing evaluation of ATSC 3.0 in India. Some of you are very involved in that, both in Korea and the US. But they are interested in offloading some of the traffic on the overloaded mobile phone network onto the somewhat underutilized broadcast spectrum. ATSC has a continuing demonstration in India showing the practical advantages of ATSC 3.0. This might be where we first see ATSC 3 chips in phones. And Jamaica has announced they're going to transition from analog directly to ATSC 3.0. They're actively planning that transition now. And that may be where we see very inexpensive digital converter boxes come into the marketplace as part of the Jamaican transition. And then finally, there's a concerted effort in the International Telecommunications Union, headquartered in Geneva, to fully document the ATSC 3 standard in all the digital television ITU documentation, and ATSC is involved in that as well. Several Korean organizations, including ETRI, have been instrumental at the ITU in making progress there. And then finally, here's some of the activities that ATSC is looking at aimed at the next steps beyond ATSC 3.0. A request for proposals on a core network for ATSC 3.0 was released just last week. It's available on the ATSC website now, and initial responses are due at the end of the year. That's, of course, aimed at standard setting. The implementation team on tower networks is looking at how you distribute signals between towers. That has significant Korean participation. The new ad hoc group on 5G harmonization is looking at where there may be commonalities and interface points between 5G and ATSC 3.0 systems. And there is a long-term planning group, planning team 4, that regularly reports on new communications technologies and makes recommendations on what new technologies might be of interest and might be relevant to future ATSC systems. So that's my brief review of the state of ATSC. I want to thank you again for organizing this forum and discussion. Apologize for my sore throat, but I look forward to answering your questions and to continue to work together in the future. Thanks.
Excellent. Thank you, Lynn. All right, we're going to move over to Sam. Now, Sam Matheny is arrived. Whoop, what's that? Okay. Okay. He's Sam Matheny is the Executive VP and CTO of NAB. And he comes with a background that's especially helpful for managing your way through digital transitions, because he was at the WRAL. I don't want to tell them how many years ago that was, but during the last DTV transition, WRAL was the first station to make that transition, and Sam was at that station. So let's see how we're going to handle this one. Take it away, Sam.
Great. Thank you so much. It's a pleasure to be with you. I just want to say to all my friends in Korea that I am sad not to be able to join you in person on Jeju. It's such a beautiful place, and but I'm happy to be with you here today. I wanted to talk a little bit about some of the things that we have going on, and one of those is the Next Gen TV logo program. You heard earlier Lynn say that Next Gen TV and ATSC 3.0 are used somewhat interchangeably in the United States. And Next Gen TV is really the consumer facing brand that has been attached to ATSC 3. And the logo that you see here is part of a logo program that is managed by the Consumer Technology Association. And in order to use this logo, you have to meet some conformance requirements. And we're delighted to be partnered with the CTA on helping to develop and implement that. The logo program really has or the ATSC has a conformance implementation team, and they are responsible for identifying areas of importance that where conformance is really something that is needed. Again, this is an entirely new standard, and while it generates pictures and audio, it does so in a much different way than other systems that have been used in ATSC1. And so making sure that the consumer has a good experience is really important, especially as we roll out this new technology. So this logo, once someone has earned the ability to use it, actually shows up on the packaging. And so this is Kelly Williams, and he is moving a LG TV set into our lab at our headquarters at NAB. And you can see the logo there, and that is what a consumer would see when they go to a retailer and they see that Next Gen TV logo. They know that they are buying a set that has ATSC3 capabilities and has met the conformance requirements of this logo program. Now, another thing that we're working on and have been working on for some time are interop events. These are events where we get together professional equipment manufacturers, we get together consumer electronics companies, broadcasters, integrators, and we take all of this stuff that goes into the new standard and we plug it in and we test it to make sure everything is interoperable and works together. These are photos from prior events that we were doing in person. This is one, probably the most picturesque one, but you can see the number of engineers and folks that we're bringing together to work on these interop events. And these would usually take place over the period of, let's say, anywhere from 3 days to a week. But with the pandemic, of course, things have changed. And now we are running virtual interops. So the NAB is supporting this with one of our members, News Press and Gazette, who is serving as the host for this interop. And we have everything available online. And we have a complete system with multiple broadcast chains and lots of different equipment in place. And we again, like to plug all of this different equipment together in various different configurations and test many different aspects of the standard to make sure everything is working together all the way through to from the very first origination of content to where it is received and used. And so we have folks that are logged in from all across the world to this system to be able to participate in these virtual interops. And it's enabled us to continue to do our development in spite of the pandemic and the travel restrictions and all of the challenges that that COVID has brought us. And this is just sort of some analysis of where you can see all of their different places along the way that you can look at the various outputs of the different systems that are being tested and what the results are. So those interops have been a key element to us advancing the technology in the United States and really everywhere. And again, some of that work does feed back into the conformance and implementation testing. So the other area I wanted to talk about is what we're doing in our lab. Now, this is something that we have not had in our past facility, but we built a new headquarters and we have moved in now, and it's in Washington, D.C. And in this space, we have a lab that is flexible use space that we configure for multiple different types of broadcast testing. This is a panoramic I took of the lab when we were doing some work with one of our members on Ultra HD workflows. And so you can see in this instance, I think we have, I think it's 6 different televisions, 5 of which are next gen TVs. We had a couple that were showing streaming and cable feeds by comparison, and we were really able to take a look at a lot of different configurations. And so in particular, what we were working on in this example was Ultra HD workflows, and we were comparing SDR, HDR systems, 2160 versus 1080. We were looking at applications, data analytics. We had sets from LG, Samsung, and Sony. Upstairs, we had a different setup where we were doing immersive audio. This is Tariq on our team. He was working to make sure that the interactive applications that we had were operational, and also with some of the data analytics that we were doing from those applications. So this combination of broadcast and broadband is a place of emphasis for us, and a place that a lot of our members are really looking to deploy new services. I'm going to walk you through some of the examples now of some of the different applications. This is one that was developed in concert with CBS based on a segment of their Saturday morning news show. This one is really commerce driven, because you can see here that it's bottom right corner, it's featuring recipes. You've got the different menus you can actually select, and then you can get the ingredients, and then you can actually purchase those right from your remote and have them delivered via Amazon Fresh in this example. So they also have a publishing division, and they sell the cookbooks that are featured in this segment. And so there were various different commercial applications of ways to drive new revenue. And so that's an important application that broadcasters are looking for. This one is one that we did with Scripps, and they are a large broadcaster who now owns Ion and is also a network, but they have a very strong commitment to local news. And this is an application that they developed that is focused on news literacy. So they're looking at how can they improve the storytelling of their newscasts, and how can they take next gen TV and use it to create a better informed audience and a more engaged audience. So, and then finally, This is an application that's a little different, but is focused on educational equity. This one was developed in concert with Howard University and their Middle School of Mathematics and Science. It is very much like the educational application that DigiCap was talking about earlier, except in this example, it was developed as a next-gen TV application. One of the things that the principal of the middle school said was, certainly not all of her students have broadband access, but she also said what you want to do is take advantage of what they do have. And she said universally what they do have is a television in their household. And so by tying this into something that they do have, she thought this could be a very powerful example. And so this actually uses the application to provide many of the same functionality that was being discussed earlier, but the user interface is all based around a next-gen TV application. So, and finally, I do want to talk about a little bit, as Lynn was discussing, the combination of broadcast and broadband, and another way that we're doing this. And we're going to show this at NAB show. So mark your calendars for April 23rd through 27th. We do hope that you will join us in Las Vegas then. And that's why you see the NAB show logo. We have this live and running in our lab now from a live camera, not playing back from a file, but we're originating a live camera feed that is being encoded. It is a 4K signal, but we are using scalable coding, and we are delivering some of that signal in a base layer over the broadcast, and the rest of that signal is being delivered over a broadband network. And when the receiver gets that live camera feed that has been encoded using the scalable coding, it has a signal that says, hey, there's an enhancement layer available. It goes and gets the broadband connection and puts that together. And one of the reasons this is really important to us is also because of the way that Lynn described we're doing channel sharing. So our base configuration in channel sharing is usually a 1080p signal, but by combining broadcast and broadband in the long term, it could provide a pathway for broadcasters to be able to provide that 4K picture to consumers. So that's something that we'll be showing at NAB show. We hope to see you there. I want to thank you all again for your time, and I look forward to your questions.
Great. Thank you, Sam. I didn't realize NAB had so much going on behind the scenes. Good to know. Okay, now we're moving on to Ann Shelley, who is Managing Director of the Pearl TV organization and Pearl TV Progress Report. I would imagine you've got quite a lot of progress. Pearl really has been the party responsible for motivating the consumer electronics organizations to come in and join the ATSC tent. And we've been getting some pretty good news from them lately. So Ann, why don't you give us some more progress report?
Thanks, Josh. I really appreciate being able to speak to everyone. I think the last time I was on Jeju was 2018. We had an opportunity to make kimchi with Jay as the lead. That was really fun. I have some great shots from that. I didn't include them in the presentation, but I do hope that the next presentation we can actually be present for. So I want to quickly just share the promotional advertising that's going to be running nationally over about 30 markets in the US over the holiday season. We just announced our holiday ad campaign, and this is really to promote the next gen TV logo. There's a little, we have to raise the consumer awareness of why would you want to purchase a next gen television. So I'm going to play that first. I think it's a little easier than going into the, let's see, share my screen. Okay, it should come up. And
the future of television has arrived. Next Gen TV is here, and broadcast television will never be the same. Immerse yourself in stunning video with brilliant color, sharper images, and deeper contrast that'll make you feel like you're really there. Feel the power of movie theater quality sound that lets you hear every voice clearly and offer offers consistent volume across channels, enhanced with internet content to get the most out of live sports, live news, live events, and more in real time. And with Next Gen TV, the TV you buy today is designed to be upgradable with the advancements of tomorrow. Make sure your next television comes built with the unlimited possibilities of Next Gen TV. The future of television has arrived. Learn more at watchnextgentv.com.
Great. So I wanted to show that to you because I'm going to talk a little bit about the consumer in the US and how we're promoting Next Gen, which is a little bit different than what you've seen. I've got to get out of here and get into my presentation. Apologize, but here it is down here. So here we go. So just before I do that, just to talk a little bit, Pearl, as you know, has been working on the next generation television standard for a fairly long time. We have now 9 broadcast station groups that are part of Pearl, and we are partnered with 5 networks. That's ABC, CBS, NBC, Fox, and Univision to help to launch and develop the platform. And it includes 2 parts. It's the underlining infrastructure that's required, so the content security protection, we're managing transitions, station operations and service integrity. We have to make sure that the service that we're offering is meeting the quality levels that the receivers expect. A common TV app platform, which I'll talk about. We're also doing data delivery to automotive and SFN testing, and I'll cover that. But the other piece that we've done a lot of work on is a consumer. Why would a consumer purchase a next-gen TV set? What are the features and attributes that we had to launch with initially to meet a consumer's expectation? The other thing we are doing is working with the cable companies to ensure that we can distribute next-gen to them. So I shared that. So Sam mentioned the next-gen TV brand. What we've been doing is taking the brand and taking the messaging and working with consumers to understand how they react to the brand and how do we get them to understand what it is and be motivated to purchase a television. And that's been an effort for the last 3 years where we've done extensive consumer research. The ad that you just saw is one that we ran last year in 6 markets over the holidays to test out the messaging. We worked closely with Maggot Associates, which did a survey. And the power of broadcasting is just demonstrated in the fact that 1 in 4 respondents saw the ad in these markets. And 73% positive. They really responded well to the advertisement. The piece of the advertisement, the piece of the features, though, it was multiple different reasons they were interested in next gen. I know in Korea it was predominantly around 4K. Here it's also these other features like the enhanced audio, the Dolby audio system really played well with consumers that they would actually purchase a television just for that. The other was this notion of upgradability. They expect to get new and better on all their devices. They're used to that with the carriers, with the cellular companies. It's pretty hard not to get a 5G phone right now or hold on to your 4G phone in the US because the carriers are pushing to upgrade you. Similarly, consumers, when we tell them about next-gen TV, they want it regardless of when 4K comes. And so that's a positive aspect of the standard, that it's upgradable. So for this reason, we are really bullish on the sales for next gen. We think they're going to do much better than the CTA projections. And we believe that CTA will be upping their projections next year. But if you think about how fast these TVs will scale and you compare those to 4K Ultra HD TVs, DVD players, even streaming players and digital displays, we're going to outperform. And our projections puts us at 45 million sets at the end of 4 years. We think that's very achievable. and we're excited about it. We do know that there's more TV manufacturers coming in. I think you probably saw MediaTek announce that ATSC3 is included in their TV set. And we do know of one very big company that just announced they're making a TV in the US is going to include next-gen TV, probably in 2023. So we are organically rising on the CTV sales. In terms of transitions, stations, we have 35 plus markets on the air today, covering 45% of households. Just in December, we'll be turning on Houston, Washington, DC, and LA. We have the other big markets, New York, Boston, and a few others turning on first quarter of next year. You can track all of this on www.watchnextgentv.com. That's a website we sponsor as part of the brand campaign. This is where consumers are going to find out about NextGen, and we can see their activities. So when we launch a market, we promote heavily in the market, and we can see them going there and clicking and with high interest in these TVs. So I mentioned the interactive platform. What Pearl's been working on with our network partners is a common framework for that platform, or for those applications. Really what it is an extraction layer that allows the broadcasters to build applications and the application developers to have a common way to access the browsers in these televisions. And so we have agreements with Samsung, LG, and Sony to do this. We're extending those out to the new manufacturers. But we have live on air in over 70 markets right now in the US, live applications that are running. Sam talked a little bit about some of their development work. This is actually real. These are real applications. So consumers are clicking. We can see the data coming off of the TV sets. We actually have data coming out of, I think, close to 90 channels because we've launched a test validation tool. A lot of the work we're doing right now is to ensure that the data that's coming back is correct. Broadcasters have included the correct fields when they're entering their global SIDs, codes, and things like that. So there's a lot of stability work still going on right now to ensure that what we're transmitting over the air and what the receivers are receiving are working, and that we have a service desk for and all kinds of things we're doing with the manufacturers. So again, we're gonna build and stabilize and build the brand phase. I see that lasting through 2022 with a hockey stick effect in 2023. Meanwhile, other activities, we are very interested in non-real-time data delivery to automotive. We launched the Detroit test track back in December 2019. It's an open test bed where multiple major auto OEMs that are located in Detroit have access to. I can't list those automakers' names here because they're under strict NDAs. We're also working with tier 1 auto suppliers, LG, and that's a spelling mistake there. LG just mentioned that they were one of those, which is terrific. So the things we're testing, again, are map and software updates, real-time traffic updates, fleet and consumer services, coverage completion, which I'll show you some coverage maps in a second, cellular redundancy, and hybrid delivery. The reason why I was asking my questions earlier is any use cases that you have completed or test results that are done with ATSC3 in Korea, we would love to see those. Those would be really helpful as we're benchmarking use cases that are actually being provided to us by the automakers. So these are use cases for file delivery that they're currently getting bids on and are paying the carriers for. And we're trying to show that we can produce that in a much more economic way to these automakers. So here's just an example of a paper that we did about 3 years ago, actually, showing our cost savings when you include ATSC plus cell plus SAT in a car. You know, we don't solve for all the use cases, but if you're cell only or cell and SAT only, you're paying a lot right now in the US. So carriers have a virtual monopoly on these services, and we think we have a real opportunity to come in and compete with them. So this is just a recent, the results are going to be coming out. They haven't been published yet, and I can't see who's up to this great work, but you can see the Detroit area right here. But the broadcasters also own stations going all the way out through Flint, Michigan. And this whole area is a real automotive manufacturing area. They are going to show you real handoff between the cell sites. So look at the coverage you have here and you're driving along. So this is very indicative of what you saw earlier from Digicap, demonstrating that the overlaps that you have in broadcast radio frequency topographies lend themselves well, and a handoff works. And a handoff works when you're delivering a file. So you're going to see actual real test results about that. The other thing that Pearl has done is published the first data on single frequency network and high power ATSC 3.0 environment. This is the SFN. It was a 2-node SFN. That SFN is still running right now. We actually have 6 services running off that SFN. And the results are what to be expected, improved coverage. There is a paper that I reference in here. I'm not going to go over all of these points here, but if you would like the paper, you can easily access it through the link that I have on here and/or our website. And then lastly, just to mention, we published the Broadcaster Host Manual, which is a manual for broadcasters in the US on how to implement ATSC Next Gen. It's a great guide to how broadcasters are enabling workflows and services in the US, if you're interested in that. And then again, the SFN test results. And lastly, please go visit www.watch Next Gen TV. We just launched some new Dolby Ads. These Dolby Ads showcase the audio features that resonated well with consumers. Those will be running over the promotional ads over all these stations over Christmas. This is the first time Dolby's ever done a direct-to-consumer campaign. And we're excited about it because we think it will drive consumers to purchase TV sets. And that's all that I have.
Fantastic. Thank you, Ann. Great presentation. Okay, let's keep moving along here. Ian Hoots, Director of Next Gen Development at One Media Sinclair Broadcast Group, is up next. And Ian is well known to many in Korea because he runs the Next Gen TV test lab at One Media. And he's been there a long time. In fact, so long, he was the guy who actually picked out the wall covering and floor covering of the lab when it was first built. So he has a lot to say. So Ian, why don't you tell me what's going on at One Media?
Yeah, that was like 5+ years ago at this point. So I wanted to start off by mentioning, this layers on to what everybody said, which is, Next Gen in this country is voluntary, right? So we've had to find out what's going to draw the consumer, what's going to bring them to the television. And one of those pieces is bringing HDR. And so Sinclair's looked at how we could upscale our content, how we could deliver HDR, and also because we have a mobile first, mobile device friendly mentality. There's some devices that HDR natively doesn't display well. So we're looking for a solution to that, and in that is the SL-HDR. And so we began placing up conversion in all of our stations that were converting to Next Gen, and we've placed the SL-HDR conversion equipment just beyond that. And so that allows us to deliver HDR to the SL-HDR enabled televisions while providing a backwards compatible SDR signal to the TVs that don't support it. So this is something that because as everybody has said, we have fewer bits, as Lynn pointed out, in our multiple stackings. And so carefully using our bits and not having to send, say, a mobile-friendly version and a main version, this is something that we felt would better us combining using this SLHDR1. So the way we implement that at our stations, and this is an example of Las Vegas, where we implemented it first, is we take our SDR signal and we're passing it to a Cobalt card with the Technicolor algorithm to upscale the signal from SDR to HDR, so that we can at least enhance the services that we do have today. It passes through the SL-HDR converter, which, mind you, if we had native HDR content, we could just move straight to the SL-HDR. But seeing how we generally don't have native HDR stuff yet, I mean, one day we will, we have to do the subconversion step. And so we were able to place that out for those TVs that, like I said, don't receive SL-HDR, they get the SDR version. And if they are able to, they'll receive HDR. So among the other pieces that we've been working real diligent on lately is our broadcast app, which we hope provides an early entry point to monetization. We are able to collect a certain amount of analytics about the early app, similar to what Ann pointed out with the apps and the test apps that Pearl's developed. We're able to see things like button presses, page views, etc. It gives us a good idea of how many consumers have clicked on certain things and what's popular, etc. We're able to provide things that are value added to the viewer, like weather and news. And we also package, where we can, we supply a certain amount of that content via NRT, so that if we have a unconnected set, we have some minimum level of service with even more enhancements coming over the air, over the top rather, when it's available. But it was really important for us that we wanted to provide some minimum level of service for those that were viewing just over the air, because for those that may recall Mark Aiken's situation, he's on a tin can with string out in the woods, and so he would be one of those persons that has poor broadband connectivity from time to time. So just walking through our broadcast app, and these are, we're actually fixing to re-release this. You're getting a bit of a sneak preview of our new look. We again feature weather, top stories. We also include some of our stir content again, and some radio audio only services, those of which are available right now OTT only. We're able to provide branding opportunities like this Chevrolet logo you see here. Hopefully, a small ad may be here instead, etc. There's definitely real estate within the broadcast app to begin to monetize that. And you can bet our sales guys are actively figuring out where else we can squeeze in an ad. So the other aspect of this app is we allow the kind of a representation of the guide, along with marking some programs as favorite or of interest, supporting things like a reminder if your favorite show is coming on soon, or if you're viewing another news clip and your show's about to change. One of the things it'll do is pop up and let you know that your show is about to come up while you're busy watching one of the news clips, so that you could quickly tune back to your sports show before you miss it. So to deliver all of these things to all of our markets and to support managing all of this rich media and the content that's made available to the broadcast app, we have had to spend a little bit of work and build our broadcast platform, which is a web-based interface for our local markets to be able to deploy this app into our stations, make changes so that they don't have to be a rocket surgeon to actually publish a new update, add some news to the actual app, and reprovision into our next gen station. And part of our broadcast platform that gives us these tools also provides our view of all these analytics coming back. And unfortunately, we had an issue where I couldn't get in to get you better screen grabs of that that we were working out. But at any rate, these and many other things we are busy working on. Oh, sorry, there we go. And I left off the end slides. Sorry about that. Back to you, Josh.
Okay, thank you, Ian. Great to hear what's going on at the test lab at One Media. Okay, we have one more speaker, and he is going to talk about the financial possibilities of ATSC. Rick Ducey from BIA Advisory Services provides financial projections on the kind of money that can be made in a variety of ways in the broadcast world, and specifically to the ATSC part of that world. So we'll wait a second. There we go. Rick's got his slides up. So now I also just want to prepare everybody on this call for the next thing that happens. Right after Rick Ducey finishes his presentation, we're going to flip the game and we're going to have people who are on the Korean panel ask the people on the United States panel questions. So I'd like everyone out there on Jeju Island to be thinking about questions that they want to ask these good people on the screen now who are giving their presentations. Come up with some good questions. And I understand that Paco and some folks out there, Jay will help them channel these questions off to these good people. Okay, so without further ado, Rick Ducey, why don't you show us what you got?
Sure, will do, Josh. Thank you very much. And it's a pleasure to be here with the other speakers from the US and also with South Korea as we share what we think we know and what we think we're learning. It's a pretty exciting journey and it's been underway for a while. And at events like this, you really get a sense for what people have been accomplishing, and each achievement begets new, more complicated questions and more exciting opportunities. So it's really great to take a pause and share in events like this to see what's going on. As Josh said, where I work, BIA Advisory Services, we specialize in looking at the finances and economics of what's going on in local media markets. Typically that's advertising revenue, but we also track other kinds of revenue. And I guess more generally lately, what we've been doing with a lot of our clients is looking at the intersections of business models and innovative technologies coming into media and local markets and how they meet those marketplaces. So that's how we look at something like Next Gen TV, ATSC 3.0. The marketplace, and Ann and others have been talking. Ann, you were talking about monetization and who's got commercial agreements and is money changing hands. It's sort of pre-market conditions now, but the evolution is underway clearly. And as Lynn Claudy said, there's 150 members of ATSC organizations. So there's an ecosystem developing around all of this innovation. So the thing I wanted to talk a little bit about is a view that we've been developing about what the marketplace looks like. We know a fair amount about the technology and what the technology agenda is in terms of what's been achieved and what's looking to be achieved next. And we've looked at some use cases without economics or really marketplace interaction, but here are things that could be done. And here are some target segments that could be targeted. And there's some initial interest and several examples of DigiCap and companies like SpectraUp achieving some marketplace traction. Money is actually changing hands for services. So I wanted to kind of build up a little bit of that narrative, but then get to the revenue forecast. What in the US market, at least, are we thinking about in terms of revenue possibilities? Then I'll offer a few takeaways. So when we look at revenue forecasting, mostly we focus on advertising forecast, and that's nobody knows the future. Also, I'll say that, of course, but we go out 5 years with our advertising revenue forecast for 16 media in each of the US media markets. So that's got a degree of speculation, a degree of science, and a degree of crossing your fingers. But it's a pretty well benchmarked practice. Something like a new technology coming into the marketplace like ATSC 3.0, next-gen TV, there is no market. There's analogous markets or adjacent markets, clearly, and that's what we're looking at. Like Ann shared one study showing that ATSC 3.0's data distribution capabilities maybe has a 10x advantage over cellular. Great. I mean, those are the kind of things that we'd love to see, and that factors into the way that we look at what that marketplace might evolve to be in terms of scale and character. So for next-gen TV, we figure there's probably 4 phases that make sense to think about and lots of sub-phases. And I put some timeframes around this just to give a sense. Phase 1 began before 2020, as Lynn pointed out, when ATSC 3.0 began to be adopted on a voluntary basis. But it's sort of proof of technology. We have a technology, we have a standard set of standard specifications. Here's how it works. We're building and operating it. That's what it looks like. Now we're starting to come out of that, but in things like the Detroit test bed and some of the progress we've been hearing from our South Korean colleagues about multi-frequency networks and handoffs, that's still a little bit of proof of technology moving into proof of use cases. So we're starting to see that this year with the distance education. Clearly, that's moving into not just a use case, but actually customer bases and businesses. So phase 2 we're into now. Here's what the technology can do, and let us show you that it actually does it. And in some cases, that's actually being done with ATSC 1.0 just because of its scale of deployment versus ATSC 3.0. But we're kind of in that phase 2, moving into phase 3. And there's some early indicators that we already are there in some level. And that's proof of customer bases. So is there a technology? Great. What can a technology do? And does anybody really care about that? That moves us into phase 3. There are actual living, breathing customers that are interested in this and are willing to pay money for it. That's great, because then all of these companies involved in gatherings like this have a way to earn a living. We like that. And we provide value for different constituencies, government, education, and the consumer marketplace. And then phase 4, okay, we have a technology, it can do things. People care about that in terms of customers and how many of them and how much are they willing to pay. That's phase 4. And as we've seen from some of the projections on the consumer market side, the CTA and then Ann's more generous view of consumer TV set adoption for next-gen TV by 2025, that's when we kind of kick it off for our revenue forecast. We've done revenue forecasts for different parts of next-gen TV. In this presentation, I'm just going to focus on non-core, the data casting side of things. So let's talk a bit about that. And I won't go through all these details. We're getting a bit into our timeline here for the event, which has been really wonderful. But in this this table, I just run through a few more examples of what I was just talking about at a high level. So proof of technology, we're moving from 1.0 to 3.0. We're starting to get into things like what's the data capacity? Can we establish service level agreements and meet certain quality assurance expectations? We've got single frequency networks, so distributed transmission systems, so on and so forth. Use cases, public safety we've heard about, education we've heard about, different kinds of digital signage. We're moving into automotive. There's other things I could have put in here too. ATSC 1.0, there are deployments in the field now with ATSC 1.0 receivers that have ATSC 3.0 capability or are relatively easy to upgrade, even field upgrades. And then proof of business scale, that will come next. And then we'll say, okay, what's the unique selling prospect? You could do it on cellular, you could do it on 5G, you could do it on satellite for that matter. You can do it over various forms of internet connectivity. What's the unique selling proposition for next gen TV? What's the total addressable market? And for those involved in these different business enterprises, what's the return on investment? Generally, what's the sustainable, scalable revenue? So we're starting to get into some business metrics, not just the technology metrics. I won't go through all these use cases, but we've heard about many of these use cases in the various presentations today. And they kind of break out into maybe two different axes, if you will. Who's the intended receiver? Typically, it's going to be some sort of a fixed receiver like a home or a mobile receiver like a car. And then what is the service being provided? That breaks up probably into a couple of different general categories. Large file distribution, cloud-based content distribution network, whatever, or some sort of streaming media like OTT services over the air. And we've heard about a number of different use cases here, from GPS to rear seat entertainment. I love to collect acronyms, so that's RSE is a good one for me. The mandatory logo wall, some of the companies that have been active in the US building some of these things out. And we've heard from a number of these companies and a number of the use cases, so I won't take your time to read through this table now, but Spectra has come up a number of times. Of course, Pearl and One Media has done so much great work, and Sam shared some of what's going on with NAB Pilot. And there's other companies that are deploying in one of those first 1 or 2 phases, maybe moving into phase 3. So it gets to the numbers now, the point of my presentation. So there's technology, there is proof of technology. We're starting to move into, there's use cases, there's ways to use the technology that could be interesting. And now we're starting to look at customers who say, yeah, I'm gonna raise my hand, I care. And then we get into that last scale part. So this is non-core, non-consumer, non-entertainment, non-rear seat entertainment. This is data casting for some of these new things. Adjacent markets are entirely new markets that broadcasters can enter with their spectrum and data capabilities that Next Gen TV brings. So the curve really starts its story 2022, 2023 with low dollar volumes, and then it scales up. We took our forecast out to 2023. And what we did was, for those 4 phases, we made different assumptions. Okay, low adoption, low scale, low revenue, a middle case, and then a high case where there's just going to be a substantial take up. The scale is going to grow in terms of the customer base, the numbers of services, the value of those services, and so on. So you can see just generally this curve, we ramp it up to 3 scenarios, the low, middle, and high case, to 2030, the end of our forecast period. So we're saying by 2030, with the utilization of say 7 megabits per second, and being deep into phase 4, we have a sustainable, scalable set of business offers. $15 billion could be brought in from broadcasters' use of next-gen spectrum, other than for the traditional TV business, advertising supported. Just under $11 billion for the middle case and over $6 billion for the low case. So basically, in our view, if we add this all up, we're saying, hey, you know, probably in the least likely case, broadcasters are going to be able to pick up another $6.4 billion with the use of next-gen's capabilities. If things go well, it could be $15 billion, more than twice as much of that. And then anybody in the forecasting business makes regular updates, so we'll continue to do that. But sitting here today at the end of 2021, that's kind of how we're adding it up. Now, to put this in context, I mentioned that we do forecasting of revenues for local media, including local TV, of course. So we say the key revenue sources now are over-the-air OTA advertising, basically. So that's that blue bar in the bottom. By the end of this year, we're saying about $15 billion in advertising revenue local TV stations will generate. Fast forward in that bottom bar to 2030, about $20 billion. So another $5 billion over the rest of the decade growth in advertising. Retransmission rates or subscriber fees, that's the middle bar. In some cases, TV groups earn more from subscriber fees, those retransmission fees, than they do from their advertising. And you can see that the subscriber fees, what MVPDs pay broadcasters, scales relatively nicely over this time period as well. And then in 2025, and you see it start to ramp up really in 2027 up to 2023, using our middle scenario for non-core datacasting growth, we're seeing that the middle scenario delivering almost $11 billion, which is over half of what stations are earning over the air and a good chunk of what they're earning from subscriber fees. So that's the middle case. That's kind of a look at what the revenue for broadcasters could be entering in to non-core broadcast services with their next-gen capabilities. So I'll do this efficiently here. Entry into the data marketplace, non-core, provides significant upsides to the broadcast model and the broadcast industry and the various participants in the ecosystem. It's a new infrastructure. It requires being built out. It's a whole tech stack. We've been hearing from the speakers today what that looks like and what its capabilities are and what the next steps are to improve that. The 4 phases I talked about, we're somewhere in phase 1, phase 2, maybe some early phase 3 in some cases. That non-core revenue forecast is pretty attractive, another $10 billion per year by 2030 in the middle case. And that non-core is material revenue compared to what broadcasters are generating now. So this is not smoke and mirrors, or this is not just money that's kind of, okay, we'll take it if we get it. It's serious money. So it merits a serious business commitment and endeavor. And then the other thing is, as I showed in that previous chart, this is incremental to the core business. So this is with that investment in the 3.0 infrastructure and a set of services and the whole ecosystem that goes with it. It's a significant amount of capital that would be infused into the broadcast industry. And again, we're just tracking the US industry. So Josh, there's a quick view of some of the work we've been doing that we wanted to share with you and put some numbers on some of the things that we're all talking about here. So back to you, Josh. Thank you.
Thank you, Rick. What a great way to end all the speakers, is to try and put a dollar value on everything that came before you. Okay, so can we, let's see, it is 8:35 East Coast time. Originally, we talked about this webinar would end in 5 minutes, but I think for those of us who are willing to go on, I'd like to give the Korean speakers a chance to ask the American speakers some Q&A. So if you can ask the tech folks in Korea to reorient our configuration here and get our Korean speakers back in the front row with the camera on them, I think we can move into the Q&A process, and we'll keep going. If some of the speakers have to leave, just let us know. Sorry we went over, but let's see if we can start moving toward some Q&A. I'd like the Korean speakers to start thinking about some of the questions they want to ask our American speakers. Maybe because we're running out of time, we can kind of have a more of a free form Q&A process. Instead of going one speaker at a time like we did with the Korean speakers, I think we can kind of divide the kinds of things that the American speakers talked about. There was definitely some specific technical discussions, and then there were some specific trend questions that could be asked that I think would cover pretty much all of the topics that the American speakers talked about. So just start thinking about some questions, and let's see if we can figure out how to get our configuration back here. Okay. Paco, are you hearing this? Let's see. All right.
Hello, Josh.
Yes. Hi. Yeah. Hi.
Hi. Okay.
Here
Jay
we are.
Speaking. Yeah.
Okay, Jay.
I think I researched about if there's some question from the Korean side, and I got 6 people who would like to ask some question. So, but as you say, we don't really have enough time now. So would it be possible to extend Q&A session to another 5 to 10 minutes? So maybe we can end this session by, let's see, 10:50, which is 10 minutes later than it's supposed to be done.
Okay.
All the speakers are okay for this, or?
Anne, are you okay with this? I think everyone else is good.
Good,
but
excellent. Good.
All
right, so Yeah, let us just take a minute because I think this is going to be better to organize who's going to make the question first and who's going to make the question next. Okay. So
Okay.
we're going to just organize this one here. So I'm going to just turn off the mic at this moment. 그 퀘션 먼저 하시고 그렇죠? 그다음에 윤정부님 하실 거예요. 아 있어요. 다 있는 거 있어요. 그러면 1번, 2번, 그 사이에 3번, 3번 해주시고 그다음에 위에 4번, 4번, 그다음에 박원준한테 5번. Hello. Hi, Josh. Okay, we're all set now. So, Mr. Seo Young-woo from KBS, he's gonna have the first question.
Okay.
Yes.
Excuse me, before we start,
Yes.
I just have to mention that Anne cannot continue with us. She has Thanksgiving plans and relatives that are visiting her. So we'd like to thank Anne Shelley for her contributions, but she won't be participating in this part of the segment. Anyway, sorry for the interruption.
All right, that's fine. Thank you, Anne. Thank you very much. So
Yeah.
go ahead.
Yeah, this is Young Seo. I'd like to ask to Sam. Yes, I think that it's too bad that we couldn't participate in NAB show several years. I miss, for example, IP showcase like that. So how about the IP production transition in US?
So I think the pandemic, so first off, thank you. We really do appreciate your attendance and participation at NAB show, and we have very much missed the opportunity to gather together in person. It's either whether it's me coming to Jeju or Seoul or us welcoming you to NAB show in Las Vegas. We very much look forward to doing that again. IP production, I think, has two sorts of phases to it. One, I would say that the pandemic has actually accelerated the adoption of IP and cloud out of necessity. I think a lot of our broadcast members, I know a lot of our broadcast members, the CEOs, not the engineers, but the CEOs are telling me, if you had asked me, would this be possible? I would have told you no. But I've been pleasantly surprised at how quickly we were able to adapt. And so this is sort of something that I call crisis as a catalyst. And the pandemic really forced people to adopt changes that they may have had roadmaps that would have taken years that then got compressed into weeks or months to implement. And a big piece of that is sort of IP workflows in terms of content gathering and also distribution. But I think the other facet to that is the legacy nature of a lot of the master control configurations and the notion of using SDI and using quad SDI and other sorts of more routine, I guess I'm going to say, configurations. And so I think that IP will continue to gain adoption. I think that it is certainly the road ahead in the future. And I think certain aspects of it have been accelerated by the pandemic, but other components, in particular, when you get into control room workflows, are going to be, they're going to take time because people are very familiar with and invested in existing modes of video routing and audio routing, and so the adoption of IP is going to be in a hybrid mode for a while.
Thank you, Sam. Great answer for that. Actually, initially we are gonna ask like 6 questions before, but since Anne just left, we only have like 3 more questions left. Okay, so next question is gonna be from Hyunshik Jang from DS Broadcast.
Hello, this is Harry from DS Broadcast. I think it's something related with the question to Anne, but I'm not sure who can answer. But I'd like to ask, US is now applying the signing and DRM. So what is the current status of the signing and DRM? Specifically, the US broadcasters are actually applying this one, or what is the plan for this?
Does anybody want to jump in?
I was going to say, unfortunately, I think Anne's probably the best one, but I can say that we are starting to test and obtain real certificates, et cetera, and move toward that. But yeah, the longer ask of that is definitely in Anne's court.
Yeah, and I would have deferred to Anne as well, but what I will point out is that whole system, if you will, has strong support from Pearl, as well as all of the networks in the United States. And so I would just say that they have worked very hard to develop it and have a lot of business drivers that are behind its implementation. So, but as to its actual time frame and things of that nature, I think Anne is the best one to answer that.
Okay, I'm the next. Maybe a question to Rick, especially concerning about the data casting use case, especially for the automotive, the data delivery. Just in my opinion, in order to for the automakers to purchase the data delivery capacity, I think there should be some nationwide data casting network somehow put in place in the US market. So when you do the research, do you see this opportunity for local broadcasters somehow they are working together to build up those unified network, and then they're putting value add services on top of it? I'm just wondering, how do you see that the possibility of local broadcasters working together with the new technology, and then an opportunity for that data casting services?
Sure, it's a great point. And in any industry that's innovating, you have a number of different companies that get attracted into different technologies, different use cases, different business models. So if you look at the state of the US market, there's at least a few different groups taking on that challenge of trying to build broader connectivity among the different stations. We've heard from DigiCap about Spectra doing statewide distance education networks. There's other groups looking at broader networks for emergency alerting services. Sinclair, Ian's parent company, and Nexstar have ventured together with a company, BitPath, that's building, it's trying to build out a national infrastructure. And another company, now they've recently named now their Signal Infrastructure, is looking to build an SFN-based broader infrastructure. So at this point, sitting here late 2021, it's encouraging and significant to see 3 different ventures independently rise up to try to provide exactly that goal, a much broader interconnection of stations that can provide a common entry point set of services and exit point for onloading and offloading customers and non-core broadcast traffic, datacasting traffic. So their businesses formed, capital being deployed, and things being built, and customers starting to be attracted to these services. So even in these relatively early years, we don't really see things taking off that much until 2025. The market's making some material movement that we see as encouraging to inform our forecast of revenue starting to flow in a significant manner fairly soon.
Okay, thank you for your answer.
Okay, Josh, this is it. I'm gonna just pass it over to you now.
You're on mute, Josh.
Thank you. Okay, always helps to have the mic on. All right, I'd like to thank everybody for joining us and staying up late or getting up early to participate in this exchange. I'd like to thank all the Korean folks who made some contributions that I found some of them quite surprising. I did not really realize how much was going on over there. And I'm hoping that our US panel was equally as valuable for the Korean participants. I'd like to thank Rapa for helping to organize this project and reaching out to me to help run it. I think this is a worthy venture. You know, we are two countries that are struggling with the same thing, which is to try and make ATSC 3.0 bring it into life. And as I've mentioned, when I started, it was only a few years ago when that seemed like a almost desperate effort. But over the past 3 years, there's been so many positive signs. And the posts we have passed, no one company or organization has done it all. It's been a true collaborative effort by a lot of different people pulling in different directions, pulling the consumer electronics folks, pulling the broadcasters, you know, educating the consumers. There's a lot of levers that need to be pulled and strings that need to be pulled as well. It's a group effort, and I hope that in some small way this gathering helped advance that, helped cross-pollinate ideas between Korea and the United States, and hopefully maybe some collaborative efforts can come out of this. It was great to hear Sam describe how virtualized plugfests are possible. That was quite an interesting thing, and those are the kind of tools that can help collaborate further between us, even though we're thousands of miles away, and even though there's a pandemic that makes travel between our countries somewhat unpredictable. So I'm hoping that we made a contribution today. I'd like to thank all of the speakers on both sides of the Pacific for their contributions, and that's a wrap. Thank you all very much.
Thank you.
Thank you, Josh.
Thanks, everybody.
Thanks. Okay.
Bye.
Happy Thanksgiving to our US participants, and thank you all for our Korean participants. Okay.
Same to you.
Thank you.
Take care.
Thank you very much. Bye-bye. See you again.
Okay.